Okay, today we are going to dive into the fascinating topic of total internal reflection. Yang ini dia agak interesting sebab it's apply the one that you are interesting one, for example the telescope of the kapal selam and others lah. Okay, by the end of this lesson, you should be able to solve problem involving reflection and refraction. Alright, now let's look at here. When light travel from higher, this is higher medium, kat bawah, higher medium of refraction to one with a lower index. This is lower, maksudnya N2 lagi kecil daripada N1. Okay, the speed increase. Okay, speed akan increase, V2 akan lagi besar daripada V1. And the angle of refraction become larger than the angle of incident. You can see that dia akan reflects away from normal. Okay, the ray will bend away from the normal. As the angle of incident increase, kita increasekan dia kat sini, apa yang jadi sampai awak punya angle of refraction also akan increase. Akan sampai satu masa di mana there comes when the angle of refraction yang ni akan sampai dia jadi 90 degree. Awak punya angle of incident ni ada value not 90 degree tetapi angle of refraction jadi 90 degree with the normal. Okay, this specific angle of incident is called the critical angle. Okay, angle of refraction is 90 degree, but any angle that makes by the incident, we call it as critical angle. At this point, the refracted ray is parallel dengan surface. Okay, parallel with surface. Okay, dan if you increase the theta ni, theta initial incident angle more than the critical angles, it will result in total internal reflection. Dia akan reflect, dia tak ada refracts dah. Dia terus jadi reflection. Alright, this critical angles is represent as theta C is the angle of incident at which your angle of reflection is 90 degree. At this angle, light no longer pass into the second medium, no refraction, but travel along the boundary. Dia akan pergi ke tepi. Okay, remember that total internal reflection occurs only apabila light travel from higher index to lower index. Okay, the two key conditions for the total internal reflection are light moving from higher to lower refractive index, lower M, and the angle of incident being greater than critical angle. Ingat tu. Kalau in total internal reflection berlaku, pertama dia higher N to lower N. Kedua, theta I lebih besar daripada theta critical. Barulah total internal reflection berlaku. Alright, from here, from the critical angle can be calculated guna Snell law. Let's start with the full equation. Kita ada N1 sin theta 1. N1 ni is the one yang incident angle ada. And then equal to N2 sin 2 sin theta 2 where our theta 2 here is now 90 degree sebab kita nak cari critical angle ni. Okay, by that sin 90 is equal to 1. So sin theta critical, we can find it using N2 divided by N1. Where N1 adalah the highest index, N1 mesti lagi besar daripada N2 here. Okay, N1 mesti lagi besar daripada N2. And then, that's all lah. Then theta, sin theta 90 degree yang kita nak cari. Alright, let's look at the representative fiber. Apa kegunaan total internal reflection ni? One of that is fiber optics. Fiber optics are everywhere. You might have heard of fiber optic cable in discussion about the internet, phone system or cable TV. These cables are amazing because they can carry digital information without long loss of tak banyak loss of energy, loss of signal across a long distance at high speed. So, what are fiber optic line made of? They are actually a strand of optical pure glass as thin as a human hair. Inside this one, sangat nipis. Each tiny strand can transmit information through light, okay, making them incredibly efficient. Fiber optic are not just used for data transmission. They are very helpful in medical imaging, where doctor can use fiber optic to look inside the body without making large incision. They are used in mechanical engineering to inspect hard to reach area in medicine, sometimes like for telecommunication and others lah. Fiber optics works on the principle of total internal reflection. Okay, you dah belajar kan tadi pasal total internal reflection. This means that light can travel for here, you akan nampak kat sini, can travel down the fiber optic and then dia akan total internal reflection without refraction, and then it will travel without escaping. When light hit the battery at a certain angle, it reflects completely back into the cable. This keep the light inside the cable, allowing it to travel long distance without losing the signal. Okay, this technology biasanya digunakan dalam telecommunication, medical treatment, and saya dah sentuh tadi pasal mechanical engineering and so on lah.